Hey guys, so today I'll be presenting on optimizing mobile mapping workflow using some new releases we have recently, both hardware and software. So I'll kick it off with the general MX portfolio many of you have probably seen before, but then we did release now the new MX90, it's like our premier mobile mapping solution. So I'll dive into that a little deeper, talk about the MX workflow in general, and maybe some tips and tricks to improve your projects going forward, no matter what system you're using. Then I want to dive into this Applanix LiDAR QC tools. The name is misleading, but it's kind of more of even like a cloud-to-cloud registration tool, but it's very interesting, and I'm really curious on how this continues to develop in the future. So we'll talk about that as well. And then I'll bring my colleague Scott Braden up here to talk about some real-world projects that we've handled recently in some really challenging environments. So we'll dive into some real-world applications as well. Quick intro about me. My name is Justin Brooks. I was born and raised in Clearwater, Florida, nearby, so I'm a crazy Florida man, as you might expect. I got a bachelor's science of mechanical engineering from UCF here at the main campus, though. Yep. So this is all, kind of my old stomping grounds around here. I've been in the industry for almost 10 years now, which is crazy to think about. But I've had a variety of jobs from, working integrations before these systems came in a turnkey, solution, to actually doing these projects in the field and delivering them to utility companies or DOTs. And now I'm with Trimble, kind of educating the dealers and assisting customers, taking the voice of the customer back to the engineers, and trying to increase the utilization of these systems across the board, right? And I mean, my title is essentially an applied geospatial expert, but really you guys are the experts. Every time I come here, I learn a lot from you. The power users are essentially you guys know more than I will ever know. So Ted, everybody, thank you for putting this together, because I think this is one of my favorite shows every year. So first, gotta dive into the mobile mapping portfolio here. And again, this might be familiar to many of you guys, but we have the MX7 here on the left, which is our imagery-only system. Now it has integrated, PAWS, GNSS, and IMU with the Ladybug imagery. So you can kind of think of that as like your Google Street View kind of thing, and we'll talk about that a little more here in a minute. We have the MX50, which is our mid-range system. This one's actually using Trimble profilers, same profilers from our static scans. So it's a bit cheaper, and we're limited on range and density compared to the high-end system, but still very capable and has some beautiful data that we'll get into as well. And then now the new MX90, which is our premier solution that I'll dive into in much more detail. But quickly with the MX7, you got 2 terabytes of internal storage. You have that 30 megapixel camera now, which is limited for today's applications in a lot of ways. But it does give you, again, a lot of flexibility. It's very simple operation, very easy setup. And then you could definitely take your photogrammetric measurements and extract things you need right in Trimble Business Center. So everything's kind of like a smooth workflow just to capture what you need. A lot of people actually have been using these now more recently for just asset management and construction kind of tracking projects over time. So I've been impressed, actually, that people are still finding really good use cases for the MX7 now. Something to consider, but still imagery only. And that's where we get into now, the mid-range Trimble MX50. This is using the Trimble X7 profilers at roughly 1 million points per second and 250 scan lines per second, which, again, is limited nowadays. 5 years ago, that would have been incredible. Now, not so much. But what I'm really impressed with is the 2 millimeter precision. So it's a really tight point cloud, even compared to the MX90 with some of the Regal sensors. It's closer to 5 mils. So it's really sharp, really beautiful point cloud. Our filtering algorithm is really good now that it seems to take out everything we don't need, keep all the stuff we do. So this has really been blowing up on the utility side. Seems like a lot of utility asset management guys are starting to feed into these types of mid-range systems. But I do want to note that we're limited to 80 meters max range. So there is a bit of a limitation there on the density and the range, but still a really capable system. And I do like to also highlight that it's the same platform as the MX90. So we're kind of lucky on the Trimble side. We get to leverage our dealer network. Sometimes people will buy, for example, a 50 for most of their applications, but if they ever need an MX9 or a 90, oftentimes some dealers allow rentals and things like that for certain projects, that you could keep your same control unit, your same rack, everything that you would use for your normal MX50, you could also use with the 90 as well. Now, getting into the 90 itself, we just released that this year at GeoWeek. And really, the only thing that's changed since last time I was here and presented on our V2 system is the Ladybug 6 camera. But we do have the Regal Vux1 HA22s Each of those are getting, I believe, 1.8 million points per second per scanner, and 250 scans per second per scanner. So incredible density, even at highway speeds. You're going to capture everything you need. Most of the time now, we're even turning down the scan rate and capturing less data. But that's also going to extend the max range. I mean, I think the max range on the MX90 now is upwards of 400 meters, which is insane. But with that, it does give you more context and a lot more information to start your extractions from. The 72 megapixel spherical camera, certainly a step in the right direction. Ladybug does a great job with exposure compensation and stitching the panoramic together. But we also have the 12 megapixel planar cameras. And now these are a smaller field of view. So believe it or not, these frames are still much sharper and higher resolution than even the new Ladybug. And these are really good, again, for reading signs, pole tags, things like that as needed. But I also like our backward down-facing camera, which is great for some of pavement analysis tools and things that are going to be developing in the future here. But I also like that the backward down-facing camera actually has an further field of view, so all of that resolution goes into essentially getting more lanes instead of more resolution. So kind of could show some of that later today. We'll have this system out back if you guys want to come check it out. And I'll go into a little bit more here with the new Applanix AP Plus boards in the IMU and the control unit. So let's break it down a little bit further. And here's some corporate verbiage for you guys. Premium, productive, simple. I always like you to show off some of these things. But really, again, guys, the workflow has come so far compared to our time at Regal and integrating these systems and having to register things in a really difficult way. A lot of this has now become very simple to use, and it's definitely made my life a lot easier. But on that note, here are some of the new adjustments. We've upgraded the IMUs, the camera, and we've ruggedized the control unit a bit more. That was kind of our weakest component in some of our old systems. So now we've ruggedized a lot of those pieces that used to fail the most. And with the AP Plus board here, there really isn't too much of an improvement in quality of the data. Now, there is marginal improvements, and at scale, it makes a big difference. We're actually talking with Caltrans right now. They're looking to rewrite a lot of their specs that essentially many other states use now. And they may be able to extend out their Type 1 control layouts a little further than they originally wrote up years ago because the technology is improving. But in general, these boards are just smaller, lighter, lower powered, easier to integrate, essentially, for third-party users. So that's definitely a step in the right direction. And the camera upgrade from the Ladybug 5 Plus to Ladybug 6. I don't think these pictures here, especially in the slides, do it justice. I'd be happy to show you guys some data, but the Ladybug does a great job now of getting that full context, all the information you might need from panoramic imagery. We also now have options to colorize the data with either half resolution or full resolution, so it can really speed up your workflow. And even for navigating through the data set, same thing. We have multi-resolution options. So that could really be a big help when these data sets get massive now. So instead of bogging things down with full resolution, you kind of have the options to switch between full or half. And the new CU2. This is one I'm excited about as well. It's mostly just upgrading the hard drives and the hard drive bays. We've also simplified a lot of the internal components. So now many times our dealers can do a lot of the servicing in-house. And the internals are much simpler to deal with now. But again, these are backwards compatible with old systems and things like that too. So nothing you need to worry about as far as keeping up to date with the newest hardware. But this is certainly going to be a step in the right direction as well. And just a quick recap, this is kind of everything that would come with the system, essentially. You get the unit itself, control unit, a power unit that allows you to hook right up to the onboard power of the vehicle. You do not need a separate power source. And now you certainly can, and depending on the application and the platform that you're setting up on, you could certainly do a couple deep cycle marine batteries, or these new lithium batteries are great. But we don't really limit you on a certain type of power. We kind of leave that flexible, and that power unit will help condition and step up that power no matter what you're using, to make sure we get what we need for the system itself. We've upgraded our hard drive space. I should have mentioned that as well, from 2 to 4 terabytes. So again, these data sets get massive, guys, and data management is more of a concern than ever. So having the 2x2, 4 terabyte hard drives, are much better now. And usually that 8 terabytes, we usually equate to a week of scanning, roughly 8 hours a day, but we still obviously recommend having a backup set just in case, swap at the end of the day. Trimble Mobile Imaging is our field software we'll talk about, and then we'll dig deeper into POSPAC and TBC a little bit as well. But I also like to highlight quickly, and I've kind of alluded to it, but it's really nice now that we have this kind of tiered support system on the Trimble side, where kind of the first line of support would be the dealers themselves. You know, you can go right to them. Many times now they have their own dedicated subject matter experts that have done these types of projects before and can usually help answer questions very quickly and easily. Anything they can't handle, my small team at Trimble can usually step in. It's me, Skylar, and a couple other guys that work specifically with mobile mapping equipment. But then, of course, we also have Trimble's imaging support, which is worldwide 24/7 support. Does a great job with them too, but I think that three-tiered support definitely allows you to always have somebody that's going to pick up the phone, essentially, and be there for you in the field, which you've probably all been there when everything goes wrong. You want somebody to try to at least work through things with, right? And the service centers now too, which is great. Instead of having to ship things all the way back to Germany to get it fixed, we now have these service centers all throughout the world. The one here is in St. Louis. We're talking about another one on the East Coast as well. So all these are starting to pop up, makes support and servicing much easier from our perspective. Now, for optimizing the workflow here, this changes depending on the user and the application. But for the most part, I'd say most of our customers are kind of doing this workflow here, where they are using TMI in the field to capture the data. And we have all types of real-time performance metrics and things so you can make sure you're capturing the data you need. We're doing our processing in Trimble Business Center, TBC. And by processing, I mean, you know, point cloud generation, registration down to control, registration cloud to cloud, maybe some classification, but at that point, people are usually kicking it right out into TopoDOT to do their extraction. And then TopoShare is now a tool that's been developing more and more as well. It's a great sharing platform too. On the capture side, we do like to emphasize that you can use like any capture device. So any Wi-Fi enabled device can operate the system. So even if your laptop dies in the middle of a project, you don't lose any of the data. All the data is stored on the control unit. You can just open up your phone, tap into the system, and finish the project properly. So I think that is an advantage for sure. I've lost data before when your collection device dies. And also, again, too, in real time, you're going to have these like real-time performance metrics just to make sure that you're capturing the accuracy that you need. We still recommend a few best practices like dynamic alignments and static sessions, which I'll talk about here in a second. But I do like our interface, and I often joke with people now on demos that if I gave you no instruction whatsoever, you'd probably be able to figure this out within 20 minutes or so. It's a very easy interface. And then processing, we do all that in Trimble Business Center for the most part. Now, we used to go through Applanix first, right, to do our trajectory processing. We've actually implemented now, because Trimble owns Applanix, we've implemented most of the mobile mapping workflow into TBC as well. So now Trimble Business Center could be your one-stop shop for all of your LiDAR and imagery trajectory processing. So that is nice. But what I'm about to talk about in a little bit with the LiDAR QC, that is dedicated to POSPAC alone for now. We are talking about integrating these things into TBC more over time. But it is interesting now how Trimble Business Center is trying to kind of bring it all into one place, make it easier to use for the user, less softwares and licenses and things to deal with, which is always nice. And then, of course, on the extraction and share side, I don't need to go too much into this because you guys are learning this week, or you certainly should be. We highly recommend TopoDOT's tools for basically most applications that mobile LiDAR would be sufficient for. And nowadays, again, the workflow is top-notch. Productivity, you can't really beat some of the TopoDOT workflows here, especially at scale, massive projects, collaborating with multiple team members. Now, this is kind of the thing that I'm most excited about going forward. And again, I don't know where Applanix and Trimble comes up with their naming conventions sometimes. They don't always make sense to me. But basically what this is a data agnostic, hardware agnostic. You could use this with any of your LiDAR systems if you have Applanix. And on that note, I've only used it with Velodyne sensors and the MX50, MX90 so far. But we can open that up just depending on your bore sight calibration values and stuff you need to punch into POSPAC. What this is what I'm most excited about is the smart trajectory adjustment. And just think of it as a cloud-to-cloud registration, basically. But now it's happening up front, like kind of right in the Applanix side. And they have all of the trajectory information, the positional RMS values, PDOP, all that good stuff. They're now going to correct the trajectory based on the best solution in that area, especially if you have a lot of overlap. And I have an example right out here in the parking lot where we just did one scan, turned on the scanner, and drove a terrible trajectory that I would never recommend. And it is pretty incredible when it works, how it ties all this data together to one beautiful homogeneous point cloud. And from there, you could then bring it into TBC, tie it down to control further, things like that. But I know Ted and I were even talking about nowadays, a lot of times, especially for these massive projects, the relative alignment is really important, if not more important for some applications. And this is the type of tool now that up front, before you even bring it into TBC, can tie everything together. And again, when I've seen it work, it's pretty impressive. Usually, registration tools are hit and miss. Like they work a lot in some cases and not in others. Whenever this tool has enough overlap and works well, it's like a beautiful, perfect point cloud. Now, they also have an auto bore site calibration and point cloud generator that's part of this tool. So again, you could buy this even as a modular, software component. You don't necessarily have to have a Trimble mobile system. But this is interesting, and it's still in its kind of V1 phase. It's been in development for years. If you guys talk to any of the Applanix guys, they've been kind of talking about this now the last 2 Geo Weeks. But now we finally have a usable tool, and I think this is going to even change, talk about workflow optimization, it's going to change the Trimble workflow over time, I think, and really simplify and speed things up. And just some examples here of you have all this fuzzy data up top, and then once you run this tool, it brings it all together. But what it's doing is essentially transforming the LiDAR data into a bunch of voxels, and they're using LiDAR clusters, turning them into voxels, and then aligning these in areas where they have any overlap. They're kind of tying it down, again, based on positional RMS, PDOT, whatever run was best. And then now using even their ProPoint technologies and some of the things here to even tie down the data further in areas where you don't have overlap. Been really impressed by this. And you could export it out to any format, industry standard format you kind of need. So again, you guys are probably really familiar with registration stuff at this point. Don't want to, go too far into this. But typically a trajectory like this is what customers might send to me sometimes and ask why the data isn't lining up, what went wrong. Well, oftentimes we try to avoid doubling back on yourself in the same scan file, right? Because inevitably you're going to have shadowing. The GPS constellations are changing, IMU values are changing. Even within a few seconds of doing a U-turn, there is going to be some offsets there, right? And if it's in a single scan file, you can't register those two things together, at least historically. Now, we just did a test out here, right at the UCF Rosen campus, and that parking lot would be a pain to survey traditionally. Now, I mean, again, we kind of even tried to screw it up and just threw it together. And with this here, I kind of only took the cross sections of a couple, but in that area, there was like 4 or 5 actually scans that were all about, 8 centimeters apart. And then afterwards, when you tie it together, it kind of is, again, one beautiful homogeneous point cloud that from there we can start to extract things or tie it down to control to get it, absolutely accurate as well. But I am excited about this going forward, and especially for projects, something like this, where even a traditional control layout for mobile mapping would be a nightmare here. And now a tool like this might be interesting, might really help speed up and simplify this process. So we can talk more about this afterwards. Please feel free to come ask me about it, and maybe we can even run it on a few of your challenging data sets you guys may have and see how it works. But I am most excited about this going forward. So we'll see what happens here. And even Applanix, sometimes they have, promotions that say like you don't need ground control anymore and stuff. I'm not quite there yet. I don't trust it that much. You're always going to want some control to validate your data, of course. But it is getting better and better. And now, again, Caltrans and some of these other guys are starting to stretch out their control networks more than they previously thought possible. So kind of keep all this in mind. And with that, before I now pass it off to Scott and kind of talk about some of our challenging projects we've overcome together, I did have a few of these slides in my last year's presentation, so I don't want to go too deep into it here. But some of you out there don't actually collect any of the LiDAR data. You just do some of the processing. And it is kind of important to know where your error sources are coming from and how to mitigate them even. Now, of course, in this case, GNSS geometry and outages are going to be a big one. Baseline length from the base station could be important, but nowadays you don't necessarily need an on-site base either. You can leverage CORS network or Trimble RTX satellite-based corrections. So all this stuff are just things to be concerned of. And as we talk about these real-world projects, these will all come into play. Of course, it all comes down to these things. If you do these 3 things right, you're very rarely going to have major issues in processing. So again, these aren't necessarily required, just my personal recommendations that when things go wrong, it's usually one of these was missed. So base station within 30 kilometers, logging at 1 second really helps. 3 to 5 minute static session before and after, and then a dynamic alignment. Because if you think about it, even if you have two GNSS receivers to get your trajectory, your heading, there's still a hardware component to the IMU. So sometimes even in TMI, all the values will come in perfect. It looks like you're going to have the best data ever, but you still haven't shaken up the IMU enough to find its proper alignment and get the best measurements. So I often recommend a dynamic alignment too, and this is, again, depending on any system you're using. Maybe we don't always promote that as needed, but these things will certainly improve your data quality if you do them, just based on the physics of the technology. And of course, ground control. Again, this is kind of a little outdated now, but targeting and spacing are really important. And depending on your GNSS availability, you could stretch out your control targets a little more or less. Now, again, all this, I just kind of give a quick recap, because now Scott can join me up here and talk about some real-world projects that we've dealt with this year, and in some really challenging environments, and then maybe even how we overcame some of it. So Scott Braden with MJ Engineering, guys. I might need to click the button there.
There we go. Okay. Thanks, Justin. Just going to talk a little bit about a few projects that we've worked on that kind of integrate the MX90 and TopoDOT, and really try to highlight a few of the challenges that we faced during the collection and processing of the data. Also wanted to say thanks for having us here this week. We've been using TopoDOT for quite a while, and this is our first time we've been able to get down here, and it's been a great experience, so thank you for having us and putting this all together. So the first project I'm going to talk about was in Queens, in New York City. Our client was the New York City Department of Design and Construction. The project itself is a stormwater management project. They're looking at improving drainage through like permeable pavement and other stormwater mitigation efforts to help when they have large stormwater events. Yeah, so as you can see, this is the zoomed out map doesn't quite do it justice, but this was a very significant chunk of Queens that we mapped. And as I mentioned, it was very challenging due to a variety of factors, including poor GPS, a incredible amount of pedestrian and vehicle traffic, tons of stop and go traffic, and also tons of obstructions in terms of parked cars along the roadway. And the challenge for us in this was mainly figuring out how to drive it and set control for the project. So we had to obviously put down a ton of chevrons at various points along the project extents, so that we were accounting for if obviously we didn't know where we were going to stop as we approached an intersection. So having a ton of control was really crucial, so that we could really tie everything down with the MX90. In addition to the MX90, we also used the Navis VLX so that we could capture data on the sidewalk, on the other side of the parked cars. Ultimately, our deliverable was a full-on topographic and utility PDF set. I think we actually handed off this data after we collected it to a few other engineering companies who did the extraction. I believe GDB is here. They did a lot of that. And I think the final product ended up being about 700 or 800 pages worth of PDFs of utility and topographic mapping.
Yeah, and this one in general too, just to elaborate a little more, I was really skeptical of the VLX and the ability to tie that data together, especially the backpack kind of system. I didn't know how well you might be able to register those two together and rectify them. But it was really interesting, especially with all those obstructions he's talking about, how basically they could drive the roadway with the mobile scanner and then walk the sidewalks with the VLX. And the way that they controlled all their data down was brilliant. I'm a believer now. Oh, go for it. Yeah.
Sorry?
I got up here on the button side.
Yeah.
I got up here. But great data fusion hybrid project. I was very impressed with the VLX side and how it was able to fill in some of the gaps. So it did a great job helping here in an area, as alluded to earlier. New York is not an easy place to capture quality data. So yeah, we definitely had to fight through this one a little bit, but it came together beautifully.
Yeah, and given the size too, we were able to drive this in a few hours. The VLXing, as you can imagine, took quite a long time, quite a bit longer than the actual MX90 driving that we did. But ultimately, within a couple of weeks, we had full data capture from basically building line to building line for this entire extent of the project. Another project I wanted to talk about, it's called Storm King. It was for the New York State Department of Transportation. Again, it presented some challenges in that it was in a very wooded area. And it may not look like it from the photo, but these cars are driving like 50, 60 miles an hour along an extremely windy and hilly road. So it's not really a project that would have been ideal for a traditional survey. Even with closures and placing the control that we did, it's pretty dangerous out there. So this was like an ideal candidate for us to mobile map with the MX90. I believe it was about 5.5 miles long. So yeah, we spent a couple hours out there MX50ing it. It took us, like I said, a few hours to drive, and the registration ended up coming together really well due to some of the TBC tools that we used, namely the run-to-run registration. With that, we basically tied down the one side of the highway and used the run-to-run registration on the other side of the highway to put the two scans together. In terms of the TopoDOT extraction, we were under a very tight deadline for this project. We had to get the mapping out in like a couple weeks. Like I said, it's about 5.5 miles. So to survey this traditionally and map traditionally would have taken us quite a long time, but we were able to really take advantage of the TopoDOT striping extraction and the brake line extraction to really breeze through this project.
Yeah, this is an example too, when like the point density of the MX50, again, it's a bit lacking compared to the high-end solutions. So driving at those speeds, some of the targets were hard to find. So with that, with TBC's tools to kind of lock in on the targets and get those points selected well, really helped in this case. But that also, going forward, I think this is one of the first big ones that you guys had to drive that fast.
Yeah, this is actually the first MX50 project we did. So, we had been using another scanner for a while, which you could pretty much, at least we drove as fast as we wanted to, and still were able to produce pretty dense data, but we realized for this we needed to drive a bit slower so that we can really see the chevrons a bit easier. But yeah, ultimately with the TopoDOT tools that we were able to use, it made this a pretty seamless extraction and mapping project.
But I think it still highlights the importance too of like the need to do some project planning ahead of time with the tools that you have at your disposal, right? Even though these tools are getting easier and easier to use, they're very simple workflows. A little bit of mission planning goes a long way, right? And I think if we would have maybe planned that out ahead of time a little better, we could have identified that at those speeds with that point density might have been a limitation, might have been some things we could do about it up front. But yeah, sometimes we have to always find ways to work around it afterwards if that's the data that we have. So yeah, this one also came together.
Yeah, that was a fun one. I just got one more here. Slightly similar to the last one I just talked about. This was a U.S. Forest Service road in basically in the woods in the middle of Maine and New Hampshire. Kind of straddled the border of the two states there. There's not a whole lot going on out here. There's pretty much a bunch of trailheads scattered throughout the project site. But the big issue is that there's a substantial river that runs along this road, and the Forest Service is worried about storm events and the river undercutting the road. So what they're looking to do is essentially, it was a study, but they're looking to figure out how they would be able to shift the road, away from the river to avoid some of those major storm issues that they had with that. And this one was probably the most challenging one we've had to deal with, and to the point where we really had to get Justin and Trimble involved to help us out, because as Justin just mentioned, the dynamic driving and the static sessions in good GPS before you start your collection are pretty crucial. In this case, there wasn't really a lot of, there were basically no areas where we could, there were no areas where we could do this. You could drive, a mile or two outside of the actual project limits, and you're still basically in the middle of the woods, as you can pretty much tell from this photo here.
Yeah, that's why I tried to emphasize too those best practices a little bit right before this, because this area was tough. I mean, there was literally no open sky in this mountainous, tree-covered area that they could sit static in for a while, for a few minutes, and do some dynamic and good GNSS availability. So I had to really dig into Applanix pause pack in this case and tweak a lot of the settings as far as making sure those lever arms from IMU to GNSS and scanners were perfect. I even opened up the elevation mask a bit from a default 7 degrees to probably 12 plus. So we're emphasizing satellites higher in the sky, things like that, which usually in open sky would have very marginal improvements. But in this case, it ended up being a game changer. So
yeah. Yeah, that's pretty much all I got, so thank you.
Okay, yeah. Perfect timing.
Any questions?
there's a few minutes for questions, guys. We'll also have the system out back too, if you guys want to come out and check it out.
Going back to that Forest Service project, I didn't catch quite how long that project was.
I believe it was around 3 miles, if I remember correctly, somewhere around there. Yeah.
Not to like discount like how difficult, and you guys, were probably able to, get the project to lock down on control and all that sort of stuff. But did you guys consider flying it with like a UAV or even mounting some sort of system to a helicopter, right tool for the right project sort of thing?
Yeah, we did. I believe ultimately I think we were pretty tight on budget on this one, if I remember correctly. And yeah, looking back, it probably would have been a good idea to fly it with the drone. But at the time, all we really needed for this was like a DTM, kind of a quick and dirty DTM. They weren't looking for super fine details or anything like that. So it was mostly in terms of like what we produced at MJ. It was like kind of an engineering study where they were doing hydraulic analysis and things like that. So in terms of what we needed from the MX90, we only really kind of needed a basic outline of the road. There's very few features. That sign that you can see there is probably one of the only signs in this entire extent. So looking back, it probably would have been a good idea to fly it as well. But like I said, for what we needed it for, we just thought the MX90 would be the easiest and most cost-effective.
Yeah, and I don't think we mentioned it either, but as he was just saying, we didn't have any control for this project either, which is normally what you would want to help tie data together in a terrible area like this. So even just because there was no control, even flying it would have been difficult as well. But with that, yeah, we were able to still bring it together in the end. It just kind of took a little bit more like working with the data, digging deep into the settings. And again, sometimes if some of those best practices, it probably weren't followed as much because it wasn't really possible to without driving another 10 miles outside of the project area. So yeah, sometimes it's just difficult, right? And this is another example that I wanted to wrap it all up, where I think that new LiDAR QC tool would do an excellent job bringing this data together, at least relatively, and getting the best possible trajectory solution based on the information available. So that's why I like to throw this one at the end, because I thought that kind of brings together that LiDAR QC tool pretty well also.
Yeah, I didn't realize about the non-control in that case. Like, I think the mobile probably would have been a perfect job. I mean, the flying it with a UAV or something like that would have had its own sets of challenges. I mean, flying in a Forest Service, maintain a line of sight, you'd have to have like a man lift of sorts or something like that. So I mean, it would have its own sets of challenges. But knowing that it's maybe more of a GIS grade sort of terrain model or something like that, yeah.
Yes, exactly.
A lot of times, too, our engineers are very interested. Like, obviously, there's no street view or anything out there, so a lot of times our engineers are just looking to get some photos as well. So sometimes we will drive projects without control, just to collect the photos so that they have something to look at.
Oh, yeah, elevation change? Road and river, you remember?
Between the road and river, there were cases where there was 20, 30 feet below you, and there were cases where it was like there was a cliffside and it was 100 feet below you. So, yeah.
And a final note on there too was actually this site was pretty far away from your office as well.
That's true.
So this was nice that they were able to, with the mobile system, capture this full contextual data that they were able to pull out way more than they thought after we locked it all down, and didn't need to go back to the project site to capture anything.
Yeah, it was about 5 or 6 hours away. So we kind of had one done opportunity to drive this, and yeah, so yeah.
So thank you guys.
Cool, appreciate it.